Okay, welcome everyone. My name is Shirley and I will be your moderator this evening. Tonight's webinar is CBCT in Practice, From Analysis to Action, Implantology. We are joined by Dr. Justin Moody, who is the founder of Horizon West Dental Group, Implant Pathway, and the New Horizons Institute, where he provides cutting-edge dental care and live surgery training for dentists. A few housekeeping rules before we get started tonight. We'd love for this to be an engaging conversation. So if you have any questions, we'd like to invite you to please type them in at the bottom of the screen in our chat box, where you can enter all your questions. So yes, please type them in even as we're presenting, and we will get to them at the end of the webinar. CE is not available for this webinar tonight, but we will be emailing out a copy of the recording to everyone who has registered sometime in the coming week. In the meantime, thank you for joining us again, and welcome, Dr. Moody. Thank you for being with us. I will pass it over to you now.
Pleasure. Perfect. Well, welcome, everybody. I always honored to be able to do a webinar and want to share. You get a little bit of a journey of mine through Conbeam CT, and it is 5:01, so let's get started. As you can see, I'm out here on the West Coast, actually in the Pacific Northwest. So here we still have several hours of daylight left. Matter of fact, people are just getting off work today. So welcome everybody, especially on the East Coast. You've stayed up to watch this, so I appreciate that. Just a little bit about me. Again, my name's Justin Moody. I grew up in a little town in western Nebraska, a little town called Crawford, Nebraska. 1,000 people. I was a fifth-generation ranch kid, so I don't have any dentistry in my background. A little bit more about myself and my family later in one of the slides. Graduate of University of Nebraska, University of Oklahoma, and I am a big fan of organized implant dentistry. So active member in the American Academy of Implant Dentistry and the president-elect for the American Board of Oral Implantology. So if anyone is ever interested in continuing on their careers in credentialing and implant dentistry, I would be more than happy to help you along that way. And at the end of the webinar, my contact information will be there: my phone number, my cell phone, and my email. So you can follow along in some of my journeys. Dr. Justin Moody on Instagram. I also have a couple others called In the Wine Mood, which is basically a chronological journey of wine and food where I go. Obviously, Implant Pathway. I'm the founder and CEO of the educational company for implant placement. And then also a proprietor of a Napa Valley winery called Titanium Winery. Kind of a shocking name for someone that's in the implant industry. But quick disclaimer, I am a paid consultant for BioHorizons and Henry Schein Dental. So, and I'm currently the board president of the New Horizons Institute, which is a 501c3 nonprofit. Let's jump into it. A CBCT scan, or cone beam computed tomography scan, is a type of X-ray that produces 3D images of your teeth, soft tissues, nerve pathways, bones within a single scan. And when we talk about a single scan, it is obviously, kind of one revolution of the machine around the patient's head and neck. And it's not necessarily, it is a single scan, but it's actually about 350 plus or minus 40 or 50 individual slices through the subject. And then the software puts it back together in a three-dimensional view for us to see. There have been lots of technology in dentistry, I think, that people could truly call game-changing technology. And I think, the generation before me, I think that was going from, belt-driven handpieces to air power to electric power. When I first became a dentist in the mid 90s. When I got out, I was still using film-based PAs and panos, and the move to digital X-rays has probably gotten close to 100%. There's probably not a lot of film-based left out there. And then there was CBCT, the cone beam, and the value that we get from a surgical standpoint. Initially, this was driven probably predominantly by the industry, the implant industry, in being able to, view all the things that you needed to see to be more reliable, more efficient in treatment planning and delivery of the surgery. Today, there's a number of CBCT machines. These are just three of many that are out there. And you can see they can be self-supportive from the floor in a stance. The X-Mind Prime 2 is wall hung. The OP3D sits on the floor but is fastened to the wall. So there's a number of configurations for cone beam CTs. And when we think about the clinical applications for a cone beam CT, it's extensively used in implant dentistry. Matter of fact, I think I can make this statement that it is the standard of care for placing implants today. I don't even think that's a stretch anymore, in that I don't teach implant dentistry without a CBCT, nor would I put implants in without it today. Doesn't mean I didn't do it in the past, but we'll talk a little more about that later. This provides detailed 3D images for precise implant placement, and it's an integral part in the fabrication of a surgical guide. And a true 3D surgical guide can only be fabricated using both an intraoral scan or any kind of digitized surface scan of the patient's teeth and a CBCT. Anything else is not a true surgical guide. Implant dentistry is oral surgery, but when we talk about the visualization of wisdom teeth, cysts, other condition, where's the nerve? It's a necessity for oral surgery today, and like I said, especially implant dentistry. Endodontics has taken a liking to the cone beam CT. It helps access the root anatomy, detects hidden canals, and it gives you a better opportunity to assess the structural integrity of the teeth. Because as we know, many teeth will exhibit signs of needing a root canal treatment. However, they often are structurally at a disadvantage by having fractures and cracks through the crown, through the chamber, through roots, and so forth. So endodontists also like cone beam CT, as we'll talk a little bit later, is the ability to collimate the radiation and the view. So endodontists don't need to have a scan from the neck to the top of the head. They would like the area around the tooth, and we can collimate it down into a nice area. Orthodontists are also using the CBCT. Now, the orthodontist needs a little larger field of view machine. So we just talked about endo, which can collimate it down and use a very small field of view. Orthodontists tend to have a larger field of view machine because they're looking to generate a pan-ceph from this 3D image. Oral pathology, again, maybe a little along the lines of oral surgery as well, but it definitely gives us the opportunity to find obviously odontogenic type pathology. We can find bone pathology, soft tissue, and it allows us to see it virtually in its 3D space. So not just off a panel that you'd be like, oh, is it deep? Is it lateral? No, the CBCT is going to allow us to be able to pinpoint the exact position of this. And we can also measure the density of bone and help in the assisting of the potential removal of any kind of pathology. And probably the newest cover to the CBCT era is airway and obstructive sleep apnea. And what CBCT does well is it has the ability to do and analyze the airway space that's available, and we can we have programs within many of the softwares to actually measure the airway space, and really helps the patient in the assessment of their potential for obstructive sleep apnea. So as you can see, this machine has a tremendous amount of applications, and I'm sure there's applications that I haven't talked to you about. Matter of fact, there's even endodontists out there that are doing guided endo. Could you imagine being able to take a CBCT, generating your access hole through the surgical guide, and then being able to have the surgical guide help you find that MB2 with a small file. And this is the fun stuff with dentistry. It really is. Here's just kind of a general image, and I wanted to show on the upper left side is a 3D rendering of the cone beam CT scan, and we can change the density of the material, the teeth and the bone and such, to be able to segment the roots, to be able to put tissue back on them. The CBCT is not historically good for looking at tissue, but when we get tissue separated, like if you were to get the lip out away from the gingiva by like maybe merely placing a cotton roll there, we'll then be able to see and potentially look at the thickness of the actual tissue. What I want to show you, though, is this x-ray is obviously, it's very clear, it's very clean. If you also notice, the patient has no metal in their mouth, no metal fillings, no metal crowns, no tongue bars, and no implants. And I'm going to return to this subject towards the end to help you in navigating or really understanding what image quality is for a cone beam CT. So as we talk about the relevance of the CBCT, it is instrumental in my diagnosis, and I want to be clear that it is not a substitute for looking in the patient's mouth itself, but it is a value. It is it's a quantitative metric that we can now look at. And what I mean by that is, in this x-ray, you can see the mandibular nerve canal. We have some other anatomical features on here. We can see some broken down teeth. We can see some decay. We can see some apical lesions. And we can start to make diagnoses such as, this is a partially edentulous mandibular arch with numerous carious teeth, several apical pathology, and bone density that is very, very good. So, and we'll talk a little bit about that later. So let's talk about anatomy first. I think the biggest thing that the cone beam CT does for us is that it allows us to see the anatomy in 3 dimensions. And anatomy for me equals risk mitigation. So no longer do we have to guess. Like, yes, maybe my 2D panel could show me where that nerve canal is, but it shows me height. It doesn't tell me, is it close to the buccal shelf? Is it close to the lingual shelf? There's so much more information. So if we take a look at the arrow in the top, you're seeing the inferior alveolar nerve exiting the mandible at the mental foramen. And you'll be able to see this when we fully draw it out in one of the next images. Now, the arrow on the bottom right showing the nerve coming down and its canal, but the arrow on the left bottom is showing a little incisal canal going forward from the inferior alveolar. So many people are looking for what we call anterior loop of the nerve, but this is a subsequent nutrient canal that doesn't have a nerve in it, but it has an artery that will feed those anterior teeth ahead of the metal foramen. So all good information to know, especially when we're going to be drilling a hole in the bone to create an osteotomy for a potential implant. And even if we look at the cross section up above, we can see that the bone is very dense, has a very dense cortical plate surrounding it, and even a very dense trabecular bone within it. Looking at this, we would be able to make a very educated guess that this implants to be placed in this jaw would probably have good initial stability. So when we also look at this in cross section, now we've got the nerve drawn in here. So we have the nerve placed three-dimensionally, so we can see that, okay, this tooth looks like tooth number 20 has an apical lesion. It could be from endo, it could be from perio, it could be an endo-perio lesion, it could be from a fractured tooth, it could be non-restorable. And you're starting to create your differential diagnosis by having more of the information. Also gives you a good idea like where that lesion is in relationship to the nerve. So if we do have to take this out, what are our risks of being able to remove this without any kind of unnecessary damage? Now, we'll go into treatment planning a little bit here in just a little bit. I want to show this because there's a number of safety features built into CBCT softwares today. And if you take a look at this, I plan an implant to be put in the tooth number 19 position. Now, I know that for demonstration purposes, I put a longer implant in here than I ever would in real life. But we put a 15 millimeter implant in there. And if you look at the upper right image, the cross section of the bone, you can see the nerves surrounded in red. And it's now in red because the software said we are in a nerve collision situation, that if we put the implant in this position, we could run the risk of hitting the nerve with the implant. So it turns the implant red, it turns the nerve red, and if we were to continue on with a surgical guide, the software would stop you and be like, hey, listen, like we're not going to be able to make this surgical guided case here because we're too close to the nerve. It's very faint to see on that upper right image, but there's a small green halo surrounding this implant. And that is what I call the biologic width. And that is, if I keep that biologic width, and it's not the kind of width that you're talking about for crown preps, it's keeping 1.5 millimeters to 2 millimeters of bone circumferentially around our implant so that it can maintain a good blood supply. Now, in some disclaimer, what I'm showing you is that the Acteon software that comes with the Acteon Prime 2. And that's what I happen to use, and that's what I have. So that's what I'm showing you in this in these images today in this webinar. What I do want you to know is like the CBCT machines in general do the same thing. It spins around your head. It takes 300, 400 slices, and then you can turn them on their side, like the image in the upper right, and be able to see it in 3 dimensions. So from a safety standpoint now, we're making this much easier on the clinician. Once you've mapped the nerve, we can always generate this three-dimensional image, and we can manipulate this image as far as we can control the contrast, or basically what the density is around these teeth and around and the bone itself. What you can see though is I've made it enough translucent that you can see where the IA nerve transcends the mandible and emerges from the mental foramens in those particular locations. Now, the CBCT also is very helpful in planning and executing advanced procedures, such as, in this particular case, a lateral window sinus augmentation. What we know is preoperatively we can measure the available space within the maxillary sinus for grafting. We can measure the thickness of the lateral wall. We can see any kind of pathology, whether it's chronic sinusitis or odontogenic infections. Like we can view those things in 3D, so that when we release our incisions and we create a window into the maxillary sinus, that we're not going to be surprised by an unknown septum, unknown pathology. And we've all looked at enough 2D panos to realize that we can't get this kind of data from a 2D image. It's just it's just not possible. Now, I added this yesterday, and that this was a case that we just saw at the New Horizons Institute. We have a number of residents that are doing they're doing a 2-year residency, and one of the residents brought me this case yesterday and showed me that we've got a impacted third molar that has what looks to be some pathology, maybe a cyst of some sort. But I want you to take a look at the upper right image, and that is, you can see if you look at the 2D pano view on the bottom, and then you go to the top, you can start to see what the size of the lesion is in comparison to the tooth itself. So, is it circumferential around this? Is it does it lend itself any space? And more importantly, when we remove this tooth and enucleate this site and curette out all the stuff, are we going to be in danger of hitting the nerve? And in this particular image, it looks like the nerve, obviously the nerve is very close, but it looks like there's solid bone, or at least some kind of a little bit of cortical bone surrounding the canal, separating the lesion from the nerve itself. Still tells me I want to be careful of that. And we also take a look at the lingual plate. Very, very thin. So when I look at this, the tooth has to come out, the cyst has to come out, but we are now mitigating our risk by understanding exactly where the nerve is as it relates to the lesion. And now we can also speak to the patient about the need to take it easy on that side until this heals, because that's a real fracture. That could be a real fracture point due to the massive amounts of bone loss that this lesion has occurred. So we'll look at it in a little bit bigger detail. There's the nerve, there's the thin lingual plate, and as you can see, this is a good sized lesion. We were able to remove the tooth. We were able to enucleate the area. We sent it off for pathology review, and my differential on this most likely is going to be a dentigerous cyst. And in the process of cleaning up this side, we elected to graft that area. So we took some of the patient's own biologics. We used We used some allograft material, some 50/50 Miniros from BioHorizons blend with some PRP and the PRF, and created a sticky bone graft, sutured it up, and I can tell you at the 48-hour mark, the patient now has no numbness and is quite thankful to have that painful tooth out of there. So again, CBCT allows us to just have all the rest of the information that we need. So let me ask you this: Are we ready to do a little treatment planning? Yeah, that's what I thought. So this is one of my cheap parlor tricks that I do with my patients. My assistants just shake their head and they're like, "You are so corny." But for me, patients love to see this image. Does this 3D rendering have a lot of diagnostic value? Not that terrible much. But the patient inevitably will always be like, "Is that my skull?" Yeah, like we would show you someone else's skull. But this is a wow factor. And when I tell you about a wow factor, is that the patient they can start to set their mind at ease by knowing they have a doctor that is using the latest in technology and has a full understanding of what is going on. So I want to show you a little video, a little screenshot video that I made of treatment planning a mandible for an implant in tooth number 30. So again, we used a collimated view, which was really just the mandible. We did take a few of the maxillary teeth with us, but we've got a very clear, very clean image of the mandible. And the first thing we need to do is kind of size it up. We're going to choose the mandible for our viewing area, and we want the plane to be parallel with the occlusal table. So here I'm lowering it down. I proved I'm parallel with the table, and I want to get just into the bone below the CEJ so that I can see the mandible in its entirety. I can move it and put it in a good position right here in the middle screen. And then if the patient's head got tilted left to right, I can make an adjustment for it with that yellow line. What you see though is this image was done very well. The occlusal table is parallel to the floor in the machine, and it wasn't tilted. Now we're drawing in our pano, and what we're doing is we're seating our focal points within the trough, within the viewing trough of the CBCT. So if you take a look, we're going to start we can manipulate the individual dots. Here we're going to make it back it up just a little bit so that we can see more of the mandible. But I can manipulate the individual dots, and I want you to watch the pano as it focuses in and out, because I'm looking for that IA canal so that I can see it right there. And I'm gonna, like I said, I can move them anywhere that I want. I can also add focal points at any time by clicking on the line at any one of those areas. So here we're going to manipulate the left side, but again we're moving it to where I can see the IA nerve canal. Now, when we talk about focal point, I think I'm going to add a dot here in just a second. There we are. There, I just put a new dot in to clean that up. Now, when we take a look at these areas that look like holes in the mandible, when we know those don't exist, but what we're looking at is a focal trough that's 0.2 millimeters in thickness. So if you look at that purple line, it's only looking at the bone on 0.2 millimeters on each side of that line. Here we moved it to 5 millimeters, and now look what it did to the pano. It lost some definition, but it gained depth of field, and now we can start to see more. Now let's take this to 10. Now those holes in the anterior mandible disappear. This is starting to look much more like a 2D panel because it's taking the entire depth of field. And here is a 20 millimeter. So now if you look at those white lines, we have completely surrounded the mandible and we can see the entire thickness. Like while I'm drawing my nerve, I like to be in that 0.2 to 0.3 millimeter thickness. So from the screen, I can scroll my slicing wheel forward and back. And I'm going to slice it forward until I find the mental foramen. I'm going to make a few dots in here. And then if I've done a good job of delineating that canal, I can make a number of marks, and the machine or the software will put my dot back in the right spot for me, saving me a tremendous amount of clicks. Here on this side, we're going to do the same thing. We're going to go to the mental foramen. We're going to click. Now we'll find, and you can move this. If you don't think that you made it in the right exact spot, you can move it. Sometimes I move it out of the way just to make sure. Now we can start to see. Now this side doesn't have near the thickness as the other because it's a little tougher to see the canal. Perfect. Now, once we've managed the nerve, now we're going to go to the implant planning mode. So here, we're still on 0.2 millimeters in thickness. This is where I'm going to drop down to 5 to 10. Now I get to see a little bit more of the mandible. The nerve comes completely through. You can see that the 3D model here for me is important because I want to make sure that the mapped nerve is coming out of the foramen and is accurate to the anatomy. I think that's really important to remember. Is we want it to be accurate. Now we can back that up. Now the blue line is our slice, so you can go onto the panel and just click where you want the slice. Boom! I want it right in between the molar, the premolar, because we're going to replace tooth number 30 in this site. So we're going to go over. We're going to click on tooth number 30, and it's going to pull up our implant planning library. Now I'm using the BioHorizon library right now. The softwares carry almost all of the implant manufacturers out there. So we're going to choose our implant. And again, you can see around the implant, there's a green halo, and it allows us to get that halo within bone. And we also want to know that we're going to move our trajectory because what we want is the functional cusp of the opposing tooth to seat in the center fossa of our restoration here. So that's the palatal to the center fossa of our lower molar. We're a long ways from the nerve. Now what we're moving is we're going to move so that we can be centered between the premolar and the molar, and that we are parallel to the contact points so that we can create a screw-retained restoration. Now, some of the nice features of the software is this plus and minus button. It will take you to the next shortest or next longest implant in that situation. And again, I'll show you the safety feature. If we get too close to that nerve, it tells you that you're going to have a nerve collision and that it won't let you, it certainly wouldn't let you plan a surgical guide from this point. Those green parallel lines above the implant, that is actually the proposed sleeve for the proposed guide. So if we look on the if we look on the bar on the far left side, guide design and model design, if you have a surface scan, you import it into the software and you can literally generate your surgical guide from this software, and you can export it directly to your 3D printer or mill for fabrication. You don't need a third-party software or a third-party laboratory to create it. So one of the things to look for in CBCT softwares. Now, I want to take you through an uppercase. Now, this is a highly collimated segment, looking at only edentulous site number 4. So here we turn this, we can see that we have a healed bony site from a previous extraction, and we're looking to put an implant in the tooth number 4 position. So again, parallel to the occlusal table, you can make minor little adjustments here, and then we'll draw our focal points so that it'll create the mini segment below. We'll create a full panel, but now we're going to be able to see that segmentation. And at 0.1 millimeter thickness, there's a lot of detail, but it's very grainy. But take a look at the enamel around the teeth. Like look at the enamel around that canine up there. Like what good, like it's incredible clarity in what we're looking at. Now, what I'm doing is I'm moving my slice to an angle that is parallel to those contact points and where I would ideally want my implant to be placed so that I could have a screw retained restoration. There's also measurement tools. So I know that I can measure the width of the ridge. I can measure the height of the ridge. And those are going to start to give me an idea of the diameter and the length of the implant that will fit in this site to satisfy the biology that we have. Let's go over to we just need to choose tooth number 4 now. There we go. We're already in implant planning mode. And now, again, we can choose whatever implant system that we're using. And you can choose the size of implant based upon the width, the available width. So we're going to go to a 4.2 by 10.5. Lengthwise, it appears that we have adequate length to get it to a crestal placement and butt up just against the sinus, but not enter the sinus. We can make sure that we are parallel to the contact points so that if we place this implant in this position, if we make a surgical guide and we get it in this position, that we'll be able to deliver a screw retained restoration that won't need adjustments and that will have good contact points. And there's our final treatment plan. What I do want to tell you is that learn any software that you have and getting quick at it so that you can do this in front of the patient. This is an amazing treatment planning tool because the patient will be mesmerized by you doing this. And I like to do it on the big screen at the foot of the chair. I just move through the scan and I get to this implant placement, and then I can say, you know, Ms. Jones, this is a really great site for a true tooth replacement solution, a dental implant. Is this something you'd like to do today? And you will get more conversions in your practice with having an in-house CBCT than not having one or even sending it to an imaging center or your neighbor down the street. So when I talk about CBCT integration within your practice, like these are the questions I ask myself. Does your CBCT integrate and talk to your practice management software? Is this seamless or does it require a software bridge? And for me, I tend to move to things now that are seamless within my practice management software. We happen to use Dentrix at the center, and this particular, the Action system, as well as many others, have a seamless integration with it. I also want to know, does the CBCT talk to other equipment in my practice? Can I send directly to a mill? Can I create something that I can go to my 3D printer? Or do I have to use third-party softwares, third-party companies, and more uploads, downloads, and all those kinds of things? And then lastly, this is super important when it comes to technical equipment. Did you purchase your CBCT, through a qualified distributor that has installation, service, and support? Because I'm sorry, whatever kind of technology you enter into your practice, there will be problems at some point. If someone's trying to sell you a piece of equipment or a software that says that they don't, they just don't ever break, well, that's not true. And the main reason is we have a whole bunch of humans in our practice that uses this stuff, and we break stuff. Trust me, I break my stuff all the damn time. This is just a screenshot of Dentrix, and from the Smart Image tab on Dentrix, I can look at my intraoral pictures. I can look at my iOS scans. I can look at my 2D images, and I can click on the 3D images and instantly launch my cone beam product. This goes to one of my efficiency points, and that is like, I want a system that has the least amount of clicks to get me where I want to go. Like I want a nice thoroughfare that is seamless with all the software that works in our practice. What's new in CBCTs? One of the new things in CBCTs today are, and this is not really new, but it's ever evolving. And that is, remember when I told you about metal in the mouth? Take a look at this. Like, even the gutta percha on the right side, when the radiation hits it, it creates this star or this scatter radiation. So we're now seeing algorithms within softwares that can start to remove, or what we call metal artifact reduction, to clean up these scans and be much more diagnostic. So that's something else that I would recommend you look for in a CBCT machine and their software is, how can they clean it up? Because I will tell you, no matter who is coming into your office to sell you a cone beam CT, they're always going to show you an image with no metal in the mouth because they're always clean and crisp and nice. My thing about image quality is like, what can they do with the image that has a lot of metal? Because in implant dentistry, that patient that has a lot of metal is our older patients in our practice that have had alloys and PFMs and lots of root canals. I'm going to tell you a little bit about myself. I told you I was the 5th generation farm kid. My dad is the 4th, but I'm the 1st generation dentist. I have no dentistry in my background. I know cows and wheat, and until I went to college, that's all I knew. But what I want to talk to you about is like the value of equipment and how people see things quite differently. So in 2006, I bought the first CBCT unit in the state of Nebraska for use in the private sector. And at the time, that CBCT install, sales tax, all included warranty, it was about $250,000, $220,000. Let's call it $250,000. Now, my dad buys a combine to cut his wheat, and it cost him about $350,000 in 2006. He thought I was crazy for spending $220,000 on this piece of equipment that sits in my dental office. Yet he had no problem spending $350,000 on a piece of equipment he uses 10 days a year. Now, I know that's not a complete apple-to-apple comparison, but it's kind of silly, right? His combine is somewhat multifunctional, right? Like you could cut wheat, and if you had corn, you could also cut corn or soybeans. But your growing season, like at max, you're going to use one of these machines 2 to 3 months of the year, where in the general dentistry office, we use it every day. It's multifunctional. And that we talked about them: airway, ortho, endo, implants, surgery, pathology. Now, we don't necessarily, we need a shed for this. Obviously, we don't have our CBCT in the parking lot, but we're putting it into our building that is already there. My dad got to spend another couple $100,000 and build a machine shed to put this in, because he certainly would want to leave it out in the rain and the snow out in western Nebraska. Now, let's fast forward to 2024 and look at the difference in the prices. The price of the combine has skyrocketed to $750,000. You can even spend more than that on a combine. But the cone beam CT, look at what the price has done. It's less than a quarter of what it was in 2006, 18 years ago. Like this tells me like this technology needs to belong in everybody's office, and the value of it is too important. So I just want to kind of put that out there as kind of a perspective. One of the interesting things is, dentists, we get paid every year, every day, in your practice. My dad, he sells his wheat once a year, like he doesn't have a check every day. Yeah, he's kind of got to spend it differently. So I want to close here with a couple of things. Like, here's what I think the economics of a CBCT look like from a pure accountant's perspective, right? Like, you've got an expense of, let's just say $55,000, but these machines can run 50 to 120,000. It all depends on, it's mostly dependent upon the field of view. So the larger the screen, the more information you need, such as ortho and airway, the more you're going to spend for the machine, because you're ending up with a bigger machine and a bigger sensor. Electricity, I don't know. I don't know what a few electrons cost to take a scan on a per scan basis. Like, I could not get anyone to answer that, but I take an entire electrical bill over a month, and in the 5 seconds that it takes to do a scan with, like, maybe it's 18 cents, it could be 5 cents. I don't know. But here's I think a very conservative estimate of like what your revenue could be. And that is, if you charged for your CBCT scans for your workup of any of these cases, the national average for a CBCT scan out there, if you're charging is $350 a scan. I'm saying you're taking one a week. That's 4 a month. And then it'll also generate a 2D pano. So for your patients that are due for a pano out of hygiene or whatever, I would say you do at least 20 panos a month at $100 a piece. And you'd probably get more than that. That's $3,400 a month in revenue. And if you take that against your $55,000, like, it takes you 16 months to pay it off. That's still a good return. And there's a very conservative revenue estimates. But let's talk more about what I think is the reality of the numbers. And some of this is hard to have a true metric to. So expenses are the same, but like, I personally don't charge for the CBCT I take, because I don't want it to be a barrier of entry or a barrier to the patient seeing if they're a candidate. Because think about the scenario where the patient's missing a tooth, your hygienist brings it up, you walk in there, you say, hey, listen, Mike, let's take a 3-dimensional image of this and see if you were indeed a good candidate for a dental implant. Ms. Jones is going to be $350 today, and it's going to be out of pocket because, most dental insurances don't cover this. The patient's more likely than not going to say, maybe next time. But what if you didn't charge? You just got them up, took them in the machine, brought them back, did that treatment planning, saw it in 3 dimensions, and be like, yeah, wow, what a candidate you are. Matter of fact, like, we should get this in there before the teeth start to shift, before we start losing bone, all these other things. And if you did that, I also think that you're probably going to take more like 40 panels, 10 a week, which is only, really a couple a day, 2 or 3 a day. That's good revenue. And then what if you've got 2 people to say yes to an implant per month? That's only 24 implants a year, but 2 a month. Like, now you've got an $8,000 return on your investment, and you're paying it off in 6.8 months instead of 16. Like, and this doesn't include the endo that you're going to find, the extractions that you'll probably do versus referring out, ortho, airway. Like the potential for treatment planning in this case is unbelievable. And it's up to you to use this machine. So this is, for me, I view the CBCT as a revenue generator, but not in the sense of like, I got to charge for every time the person comes in there, because I'm going to get it in my ability to treatment plan and get case acceptance for the work that I've worked up. that is, well, we're 50 minutes in. We do have some time for some Q&A. Is there any, do we have any questions come in?
Thank you so much, Dr. Moody. We don't have any questions yet, but thank you for that wonderful presentation. Really fascinating, that cost comparison analysis and then that breakdown on how to bill. Yeah, right now we don't have any questions, but we'd love to invite our audience to please enter questions into our Q&A chat box at the bottom of our screens. In the meantime, I had a couple of questions for you myself. What do you look for in CBCT software?
I mentioned it briefly. I look for the amount of clicks it takes me to get from point A to point B, and is it really seamless with my practice management software? That's probably my biggest things.
Okay, and a couple of questions have come in. This one's from Dr. Sam S. If you intend to do a full mouth case, if you intend to do full mouth cases in the future, what field of view would you suggest?
You know, field of view, like this machine here is an 11 by 12 sensor, I do believe, which is kind of an upper mid-sized sensor. And you get everything you need for working on real teeth and placing implants. If you're going to get into ortho, straight wire ortho, and airway, you're probably going to get a going to need a bigger field of view for that, probably in that 15 and 18 range.
Great. Dr. Sam S. also says that he is willing to buy one for his startup practice. From Dr. Dan Morrison.
Yeah, it's imperative that you get one right off the chute, out of the chute.
Thank you. From Dr. Dan Morrison, what is a good refresher course to take for relearning the anatomy due to larger fields of views?
You know, if you were like me, Dan, like it's always been a while since you've been in dental school, right? And had all that kind of anatomy. So I think there's some good CBCT courses out there. I know that Action provides a few. One of my good friends, Steve Borholt, teaches some CBCT courses that reviews the anatomy in these larger fields of view. So you drop me a note or something, I can give you some sites that you might want to check out.
Thank you. This one is from Dr. Anshuman Soni. Hi, doctor. What FOV do you recommend for general dentists for endo implants?
You know, that endo implant, like I think I wouldn't probably go smaller than an 8 by 8 sensor field of view. Now, if you're only endo, you can go down to a smaller field of view, but that's probably I think that's a good starter place for just single units and endo.
And both Dr. Soni and Dr. Sam S., thank you for your answers. They thank you, Dr. Moody, for your answers to their questions. This next question from Dr. Anthony McHale. What is the minimum FOV for single tooth or quadrant work?
Yeah, probably the same along the same lines. Is that 8 by 8 is kind of like my minimum. But I really like the 8 by 8 to the 11 by 12. Like I would just use the 11 by 12 because as you get into implants, you will you'll start to push your limits, and you'll want to have a bigger field of view.
I'm sorry, did you answer this already? Do all CBCT machines have the same footprint?
They don't have the same footprint. Some machines that sit on the floor with legs will have a wider, deeper profile than, say, a wall mount unit such as that Action Prime 2.
How do you manage your CBCT CBCT database for your patient family? Do you give it to the patient? Do you keep a record on the cloud?
Well, that's a good deal because the CBCT data piles up. I think our server in Phoenix has almost 9 terabytes of data. We we back it up. We do back it up to the cloud, and we back it up on site. Those two. I don't give the data to the patient unless they're requesting the records.
How hard is it to export a CBCT scan?
It's not that hard to export a CBCT scan. Not all machines. So remember that a CBCT scan generally generates a .dcm file, and some machines and softwares will try to create kind of a proprietary file type that makes it harder to leave maybe what you would call their ecosystem. And I certainly would want to stick with a machine that would easily export onto a flash drive, your DCM files. I see a question from Kurt Lamb. Yeah, I do think it is closer to 11 terabytes than 9. But like it's so much data. When we upgraded our server, it literally took 14 days to upload the data. It's crazy.
Are you incorporating 3D printing of your own surgical guides?
We do. I use surgical guides in the aesthetic zone almost 100% of the time. In the molars and such, sometimes the patient doesn't open wide enough and things, but I would say I use a surgical guide in the aesthetic zone almost 100% of the time.
Wonderful. Well, those are all the questions that have come in. Unless there are any other questions now, we could give you, our viewers, and you, Dr. Moody, back a couple minutes before the end. I see you're pulling up your contact info, so that's wonderful.
I just want to give everybody that is watching this live, and anybody that may watch it in the future, this is my contact information. The Implant Pathways address down in Gilbert, Arizona. My cell phone, my email, and if there's anything that you have any further questions or comments or anything that I could do to help you, please don't hesitate to contact me. That's what I do.
Well, that is wonderful. Thank you so much, Dr. Moody. That was a wonderful presentation. And also thank you, our audience, all for joining us this evening. As I said before, we did record tonight's webinar and we'll email the recording out sometime in the next week. We would appreciate your feedback via our survey that's going to pop up on your screens shortly. Thank you all for joining us again, and we look forward to seeing you on future webinars. Have a wonderful evening.